Hello and welcome to another edition of VMware's Bits and Bytes Live, the series of short conversations where I talk to experts in their field about various topics through the lens of the communication service provider. I'm Nigel Stephenson. I look after market development for Europe, Middle East and Africa for VMware within Telco Group. And what I want to do today is actually continue from our last conversation where we introduced the topic of sustainability and the framework that VMware is following to address sustainability. And in that, we mentioned a number of different pillars, areas of technology that we can dive into. Today, with the help of Lorcan Burke, field CTO of RAN, what I want to do is actually take a little bit of a step down, but not go into the deep dive just yet. So in this session, what I want to talk about with you, Lorcan, is the principles you can follow. So we're not going to go into the technical detail behind them at the moment. We'll leave that for future sessions. But what I want to do is to understand, if we're looking at sustainability, which essentially I think breaks down for most of us into a couple of areas. One is related areas. One is reducing our emissions, so the protection of the environment, and aligned with that and directly related to that is reducing cost, right, which is a big issue, especially here in Europe. So for this session, what I'd like to do is just understand what principles should we be following, and then in future calls, we'll start looking at a little bit deeper into how we enact those principles. So Lorcan, welcome, thank you for joining me. So the goal is reducing our emissions, and associated with that on the business side, reducing the costs. From a technologist perspective, what are these principles that we can follow? Is there a list? How would you define how we should be looking forward?
Yeah, so good question, Nigel. So I think if we want to, as service providers, leverage the multiple cloud platforms we have in front of us, or the different physical environments we could lay our applications on top of, we need to look at really accelerating that journey towards virtualized or containerized infrastructure. So doing that allows us to bring things onto some common platforms. If we bring things onto common platforms, regardless of where we place that workload, whether it's on-prem or in multiple clouds, we can then put consistent instrumentation and measurement around that. And once we're measuring what we're doing, then we can think about improving that. And once we know how we're measuring and improving things, this is a pretty complex environment. We can start automating how we place workload, how we condense workload, how we optimize the use of different clouds or on-prem infrastructure. And then once we've all that working, we can then think about how do we power it with the maximum amount of green energy possible, and then really shift workloads to places where we can maximize green energy. And there's an interesting side effect of green energy. It turns out it is actually in most places more cost effective to use green energy, whether it's curtailed or in the evenings, and move workload to match that availability of green energy.
Excellent. So let me see if I can play that back just to sort of capture it. So I think I captured 4 areas that we can focus on, 4 principles, if you like. You mentioned moving towards virtualized environments, virtualized containerized environments. And we'll come on to sort of what that releases in terms of capability. You talked about instrumentation. So if we've got that environment, which is by embracing that, we're moving towards a more sustainable framework, if you like. We then need some instrumentation around that environment to understand how it's behaving. We need automation because it's very complicated. There's a lot of goodness, but if you like, on the flip side of goodness is the complication that can come with these environments. And then, so those are all kind of technology solutions in and of themselves. And then the last one you mentioned was a move towards green energy, which sounds like almost taking external factors in and using the previous 3 to align with green energy. So there's sort of 3 very much, if you like, internal technology type things we can do, and then we can look outside for where the energy is coming from, and we can use this platform we've created to align it more towards green energy. So if I got those right, I think I have. Let's look at the first one. So principle one is moving towards more, or embracing virtualization, containerization more. Just paint a bit of a picture of why that matters, and perhaps if we didn't do that, what the alternative might look like.
Yeah, I guess, Nigel, we started the journey away from, if you like, proprietary closed systems many years ago. Right? So we've done a lot of work on, if you like, the first generation of getting away from a locked and closed system with virtualization. So we still have many thousands of virtual network functions running most of our networks in 3G and 4G. And then in the 5G domain, we, as an industry, decided to accelerate containerization. So really leverage a lot of the technologies coming out of the hyperscaler domain to be able to allow us to innovate faster. But the idea behind that virtualization and containerization really allows us to combine and move workloads around faster, and allows us to automate the placement of those workloads with a consistent infrastructure. And then we can use common open source tooling and infrastructure that the hyperscalers are also using.
So it's giving us flexibility on which we can then make decisions, I guess. It's
exactly
giving us that environment. And then, so disaggregating the environment then allows us, I guess, to make decisions that we couldn't make before in terms of where things would run, physically, location, and in terms of actual hardware it runs on, things like that. So that's the kind of benefit we're getting from there. And then, so moving on from that, what changes? Because we've been doing, in fairness, we've done a lot of that for a long time. Yeah. So you mentioned visibility, instrumentation. What is happening, or what needs to happen on the instrumentation side? What is the difference now that we're putting this focus on sustainability?
So commonly, if you start right at one extreme on the bottom of the hardware platforms, if we're running various compute architectures, there's a lot of states available in those architectures from the likes of Intel or ARM that allow us to condense workload. So if we can understand when that workload can be condensed, and we can understand how to condense that workload, we can expose that information and make those decisions, right? The same is true of, if we look at traffic patterns and networks, we know that there's if I'm running, say, a fixed line network on top of a mobile network, quite common, right? So fixed wireless access, I might have a very long, busy hour or busy day in the evening, but I still have quiet times. So if I can measure the traffic patterns in those networks, once again, I can start making decisions around, do I shift workload to different places? Do I condense the compute? Do I then shut things down and really start saving some energy, and therefore the carbon impact of that energy? And then once I do that, and I understand the need to bring it back up again, I can start looking at the risk of how quickly I need to recover states, or if there's a burst of traffic for an emergency service incident, that sort of thing. So the measurement allows us to do that, and it has to happen at all levels of application, at cloud platform and the underlying hardware platform.
I was going to say, as you were talking there, I was thinking, you mentioned risk, because of course it's one thing to have the ability to see the potential to turn down things, if you like, switch things off, reduce speed, reduce capacity where it's not needed. But this is something we'll probably talk about in a subsequent conversation. But especially in the telecoms environment, there is that risk element that you need to take into account. So it's no use scaling back to reduce power if you can't turn it back on fast enough. So there'd be a set of algorithms, if you like, around what you're actually capable of turning down, based on not just the ability because it's not needed at the time, but the ability to turn it back on and how fast that might need to happen. So it's quite a complex environment, which I guess comes on to your third point, which is around automation. And I presume, does AI have a part to play in this as well? In terms, if you've got all this data out the network, you've now got to implement change and make decisions around change. So that's the automation and presumably the AI piece.
Yeah, I mean, if you look at we say artificial intelligence. We've been leveraging various forms of artificial intelligence for decades in communication service providers, right? So we started with neural networks, machine learning. We've done security things with different types of intelligence. the kind of latest wave of automation around artificial intelligence does give us maybe a step forward in a range of tools to use. And a lot of what we're focusing on with our automation frameworks is to be able to expose and use those different frameworks, right? So we have opinions on all of them. We enable use of all of them, and then part of that is how do you make sure when you are using external AI, particularly, how do you make sure your data sovereignty is still intact, your security is still intact, and that you aren't giving away your intellectual property, through some uncontrolled method. So there's some quite nice things that are enabled with AI and machine learning and various of those types of techniques. A lot of the blockers for use of that are that these algorithms need large amounts of data to train them. But the one thing we know about telco, particularly in performance data, is we have large amounts of data, right? So we have large amounts of data that we use to drive our key performance indicators. So whether that's, we talked about condensing workload, shutting machines off. I mean, that's a network availability KPI. We need to be careful about that. We need to look at our end user performance, make sure we don't degrade that. But there is a trade-off to be made, and we can use AI to help make those trade-offs more effective, as we've learned from the human behavior.
Cool. And we've got a question come in, but I'll finish the flow on your principal points there, and then we'll come back to the question we just got come in. So the last thing you're saying is we move towards this more dynamic, more automated environment, more disaggregated environment. There's then this principle that says, well, we can do all of that is trying to reduce consumption, and by doing so, reducing emissions and reducing cost. But there's also this fourth one you mentioned, which is the concept of saying let's use green energy as much as possible and non-green energy as little as possible. Tell us a little bit about how that might work, what that might look like.
So this is another area we've been working on, and I mean, some of the questions coming in around new innovation, right? So this is a relatively new thing, but there's nothing always that new in the world, right? So we've been looking at in a number of grids, right? So if I look at Ireland and the Netherlands as examples, right, with significant wind coming onto our grid, given we're looking out at the Atlantic, if we can measure that available green energy on the grid, we can then match that up with the available workload or the workloads we're running inside our data centers. And in both Ireland and Netherlands, we're significant data center providers. We host a lot of people's data centers. If we can shift workload based on that green energy availability, then we can make sure that we are using green energy when it's available on the grid. So we're running some fairly significant experiments on that, both inside and outside data centers, and then looking at how we share that information with people so they can make more intelligent decisions about where they shift their workload to and use green energy, therefore reduce their carbon footprint. And it can be simple things like data backups, right? We do a lot of data backups. We move data around all the time. We deduplicate data. We move it around less often, and we put it in places where there's green energy. It's pretty likely that we'll start saving some significant amounts of carbon.
Cool. So as you say, the question, I'll just sort of, for folks listening, the question really is, where does new tech innovation fit within the framework? And you mentioned a bit there. I think in the if you call it the data center environment, the core, whether it's IT network, in that environment, then it seems to me a lot of the innovation is coming from that instrumentation. It's looking for ways of diagnosing what's happening in the network, but through a different lens. The lens now is not necessarily performance or reliability or whatever. It's that sustainability lens. So we're looking much more at energy consumption and the impact of changes to reduce energy consumption, but maintaining service levels and so on. So I guess that is an area that is becoming innovative, whereas the actual techniques, the moving of workloads, the placement of workloads, the backing up of workloads and so on, that is, in all honesty, fairly traditional technology in many instances. But it's the visibility that we're applying and then the automation on top with perhaps the AI, advances in AI to make decisions. That's where the innovation is possibly coming in the data center. The other area, which perhaps you could speak a little bit about, where there's a lot of innovation, and I think for me, this is where the net new technology is really happening, is probably in the RAN, which is also, I think, probably the most highly consuming part of the network anyway. In terms of energy consumption and cost, the RAN is typically a very big element of both those factors. So tell me a little bit about where we're seeing innovation specific to the RAN.
Yeah, and the RAN radio networks are a very interesting place, right? So the RAN technically consists of the transport network that connects the base station sites, the base stations and the antennas and the towers, lots of feeders that are using energy to move radio frequencies around the place. There's a couple of things we've done over the longest time, right? So we've moved power amps, radio power amps, further up the tower, so remote radio heads. We've then looked at the digitization. How do we digitize earlier? So the people look at the DU, if you like, in Open RAN. How do you put that out towards the site, and how do you minimize the amount of transmission required for that? People are looking at using more passive optical networks instead of traditional active networks for transmission. So we've got some significant research activities going on looking at how do we measure end-to-end energy performance in the RAN, and then how do we really look at automation of workload placement in the radio network. And then the CU allows for some pooling gain, right? So if I'm serving a number of base stations and I have a more centralized or maybe regionally distributed CU, I'm concentrating load and maybe offloading earlier in the network. Now, one of the other drivers come the other way is, big source of data growth inside these networks are short form video, if you like. So we have many hyperscaler friends who are driving lots of traffic on these networks, and they require very, very good performance for the end users. And some of the things they're looking at is how far out they can push their content. So that's the idea of having a consistent kind of cloud platform for where you put workload, the ability to break workload out and make it controllable in real time, which is what we've been doing around intelligent controllers. And then with that automation framework, how do we place that cache out on as far out as we can over time? And what I think you'll find is over the next 5-10 years, most of those RAN sites will become distributed edge data centers of some size and shape. The aggregation sites will certainly have more compute on them. And having a common cloud platform allows you to decide what workload runs there. And then how do you decide how to shut down or condense or use different control methods to put users, give them good performance and minimize the energy they use. So that's the combination of the cloud platform, the automation frameworks, and the RAN intelligent controllers to allow you to place workload and control the quality of experience for end users. So Open RAN as part of a evolution towards cloud for the entire network, pretty key component, I think, in that. And eventually we'll all get there. It may take longer than some people like, but for the most part, we've got some pretty significant starts with good networks in the US and some early signs in Europe and Japan.
Yeah, and we've got there's some interesting news trials and POCs and use cases around things like controlling spectrum and making more efficiency, actually literally right at the edge of the network in that instance. So there's, I think there's a lot of interesting new technology, new vendors coming to market, and a lot of what we're seeing in the Open RAN space, a lot of the use cases are around energy efficiency. So I think it'd be interesting to see how that develops over the next 2 or 3 years as everyone starts to pick up and roll out. So it's great. Look, as I say, I don't want to go into the detail at this stage. What we'll do is we'll go through some more conversations on sustainability and dive into some of those. When we say virtualization, containerization as a principle to embrace as a way of driving towards more energy efficient operations, green energy and so on. We'll look at that in subsequent conversations. So I think the next one we're going to talk about for folks listening, we'll go into the how do you maximize the use of green energy. So we'll pick that one for the next conversation. And I'll have another speaker actually, so no offense, Lorcan, but we'll have another speaker. We'll go into that in a bit of detail. And then subsequent to that, we'll look at the disaggregation aspect of what that delivers. And we're also going to look at organizational pieces as well. What can you do at an organizational level to develop strategies at a project management level to drive sustainability through the organization? So there's a few things there, but for now, I think that's a good summary. Thank you for that. We got the principles that we're going to follow. We're actually a hot topic. I'm also running a sustainability seminar, which Lorcan, you're going to present at a summit next month. So that's, if you're watching the recording, it's in June. So if you're watching after June, Sorry, but yeah, we're running that in London, so I think we'll put a link in the comments on LinkedIn for folks if they're interested in that. That is a free to attend summit that we're doing with our colleagues at Intel specifically for communication service providers, I should say. So if you're a communication service provider and that's of interest, and you can get to London in June 23, then we'd love to see you there. We'll post some details so you can register your interest. But for now, I think that's great. Thanks again, Lorcan, for your time. Thanks folks, for listening. And as usual, if there's any comments or any questions, just reach out to us on LinkedIn and we'll get back to you as soon as we can. Thanks for now.
Thanks, Doug.